Hi folks, it's Emily. Today we're going to be talking about the confidence intervals, but I want to kind of motivate this with an example. And we're going to be talking about a little animal called the American pika, which I think is the cutest little rodent ever. So I'll just put up this video of the little pika making its little call so you can see how cute it is. See, it's so cute. All right. All right, so for those cute little animals, we're going to think about if we wanted to estimate their mean body length. So remember, rather than collecting data on every single pika, the entire population of all of them, that would be a census, but it would also be senseless because it would be hard to get them all to sit still so we could measure them all. So what we're going to do is we're going to collect a smaller sample of pikas, measure their body lengths, and then calculate the mean. And we're going to use that to sort of estimate the mean body length of the larger population. We've been calling this inferential statistics because we're making inference about or making conclusions about the larger population based on a sample. And just before the break, we sort of talked about this idea, well, you know, if I sample one group of pikas, I might get one sample mean. And if I sample a different group of pikas, just by random chance, I'm going to get a slightly different mean. And so, you know, if we're getting a slightly different mean each time for each of these different samples, how do we know which one is actually closest to the true mean body weight, right? And so this sort of presents a problem with these point estimates. By getting one value from our sample, we know that it's not going to be exactly what it should be, but we know it's going to be close. Okay, so our solution here is rather than giving a point estimate and just saying, you know, we think the population mean is blah, 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 instead we're going to go through and we're going to give a range of possible different values. Okay, and we're going to call this range a confidence interval, okay, which is a type of interval estimate. So we're estimating an unknown parameter using a range of plausible values. Okay. Now, when I go through and create a confidence interval, okay, if I'm doing a range of plausible values, it's possible that that interval might not actually contain the true population mean. It may or it may not. The only way we could possibly be guaranteed to include the true population mean is if we had everything from you know, 0 to positive infinity, all the possible values. But obviously that's kind of meaningless. No one wants to give the interval that way because it's not actually, doesn't tell us anything, right? So what we have to do is we have to specify some kind of error rate. We're going to call it alpha that we're comfortable with. So basically, typical values are 1%, 5%, 10%, 20%. Is basically a value of the percentage of the time that the interval might not actually contain the true population mean. Okay, and rather than talk about this error rate, this alpha, we're often going to talk about the percent of times that the confidence interval is right and it contains the true population mean. So we're going to talk about it in terms of confidence, how often it's right compared to how often it's wrong. So we're often going to talk about 1 minus alpha being the confidence. That's how often it's right, rather than talking about the error rate, just alpha. It's just convention. Generally, confidence intervals always have this same form. So they're always going to start with your estimate, okay? And then you're going to add or subtract this margin of error, okay? And then maybe highlighter would be better. Here we go. So this is your margin of error. That's how much you're going to go out to the left and to the right of your estimate. Okay, so same thing. We've got our estimate here in the middle, right? And then we're going to go out to the right, some margin of error, and then we're going to go down to the left, some margin of error. Okay, statisticians have been thinking about this long and hard, how to get this margin of error. And it's made up of 2 pieces. So we've got the critical value, and we'll talk about how to calculate that in the next video. For different scenarios, depending on what we're trying to estimate, that may be slightly different. But again, we'll talk about how to get that. And then the other piece is this standard error, estimated standard error. Okay, and those two pieces are going to always make up your margin of error. And that's going to give us sort of a range of plausible values. So the next video will talk about, a particular situation for means, if we're trying to get an estimate for means, and what values we're actually going to plug in for those, the critical value and the standard error.